Okay, later we are going to learn about this instruction format. Okay, the instruction format. The instruction format, as we have said, for these another 2 registers, we only use 16 bits, but for the IR, the instruction register, we use 24 bits. So this is the first 8 bits. This is the second 16 bits. So the first 8 bits, we call it instruction specifier. Okay, that means here it specifies what instruction we are now executed. We call it instruction specifier. And the following 16 bits, we call it operand specifier. So this represents the operand you are going to process. Okay, the operand directly, or the address of the operand where you can get such kind of operand. Anyway, it specifies what operand you are going to process. So when we going to read each instruction, we firstly check the first 8 bits so that we are going to decode what instruction that this instruction represents. And then for any instruction, we go to learn about the next 16 bits so that we are going to know what kind of operand it's going to operate on. Okay. So then this is the 2 parts. How does the instruction format composed of? And then we are going to learn about the first 8 bits of this instruction specifier, okay, for the first part. So you can see we can divide the first part, the instruction specifier, into 3 parts, which is marked as different colors. The first 4 blue bits, we call it as operation code. So operation code can specify which instruction you are now operated. So this is, we call it operation code. And then this 1 bit, we call it a register specifier or 5th bit of operation code. That is, for some operating code or most of the operating code, we only need 4 bits. But for some specific one, it may be need a 5th bit of this operation code. And these 3 bits are quite important. We call them addressing mode. As I have said, the operand specifier can store operander directly. Or it can store the address of the operander. Okay, the address of the operander. So, but all these, no matter which kind of situation, here are just 16 bits binary strings. So how could we know it is the operander directly, or it is just the address of where the operander is supposed to be? We need an addressing mode defined here. Okay, that is defined here to tell you what the addressing mode it is supposed to be. Okay, so this is a simple construction of this instruction format. So let's continue to talk about the instruction format. So as we said, the format of an instruction is constructed in 2 parts. Okay, the first part is the first byte, 8 bits. The first byte indicates which operation is to be executed. For example, add a number to a value already stored in the register and how to interpret where the operand is. And then we call the first byte as instruction specifier. And then another part is we call it operand specifier. It holds either the operand itself or the address of where the operand is, right? Okay, so let's check. So the format of the instruction specifier varies depending on the number of bits used to represent a particular operation. It may be 4 bits or 5 bits. Okay. So you can say here, Firstly, the operation code. It specifies which instruction to be carried out, right? We said here, the operation code, the first 4 bits or 5 bits according to different situation. And then the register specify it's supposed to be here. We say it is specifies which register is to be used. Okay, so for example, use A register, or in fact, in the real ALU, is supposed to be a lot of registers. So here we just use A register in this chapter. But anyway, it is a register specifier for which register is to be used. And then the addressing mode is to say how to interpret the operand part of the instruction. It's directly the operand or the address of the operand. So here we introduce two kinds of addressing mode about these 3 bits. First, we call it immediate addressing mode, and second, we call it a direct addressing mode. You can see from this figure, we use 000 as this immediate addressing mode, and use 001 to indicate the direct addressing mode. You can also easily to see the difference between these 2 addressing modes. For the immediate addressing mode, when the addressing mode is supposed to be 000, it directly means the operand specified represents the operand. Okay, so that is the operand is shaded gray. Okay, so this is just its operand. If it is 001, it means the direct addressing mode. So it represents the address of the data. The address of the data. So after know the address known from here, it go to the memory and obtain the real data, real operand through the memory. So also here in the shaded gray part is the real operand. So in the immediate addressing mode, the real operand is directly stored in this operand specifier. But in the direct addressing mode, the real operand is just stored in the memory, while the operand specifier stores its address. Okay, so its address. So just its location, okay? Its location is shaded in orange. So the distinguish between the immediate addressing mode and direct addressing mode is quite important, right? Because it determines where the data involved in the operation is stored. Okay. And some instructions may do not have an operand. So we call such kind of instructions unary instructions. Unary instructions. The instructions do not have an operand. Do not have an operand. Okay, we call them unary instructions. And usually such kind of instructions are 1 byte long, 1 byte long. Okay. Here we showed some examples. For example, this part is the operation code, okay? That is this blue part, the operation code defines what operation it is. And here we listed the meaning of each instructions. For example, if the operation code is 0000, the meaning is to stop the execution. Okay, so this is a unary instruction, right? It doesn't have any operand. We also list some other examples. For example, 1100, it means load the operand into A register. Or next represents store the contents of A register into the operand. Okay. And like add the operand to the A register, or subtract the operand to the A register, or character input to the operand, or character output from the operand. Okay. We have these are several examples of the instructions in the PEP 8 virtual machine. So we show some detailed example of the instructions. For we check what these instruction means. Okay, so firstly we read the first 1 byte, the instruction specifier, with the first 4 bits about the operation code. That is 1100. We can check from this table list. Okay, so I just 1100 is this one. Okay, so I just copy it to here for easier understand. So this instruction operand represents the load of the operand into a register. Okay, so we load some operand into the A register. And does this is exactly the operand or just the address of the operand? We check the addressing mode here. 3 bits addressing mode. So it is 000. Remember what addressing mode it is? It is immediate addressing mode. Okay, so this is the operand. So this instruction means put this operand into a register. So do you know what the operand this is? This is just a 111, so this represents 7, right? 7. So this instruction means put 7 into a register. Okay, so the following one. First, we check the operation code in the instruction specifier. The first 4 bits is also this instruction. So it also need to load some operander into the A register, but the addressing mode transferred into direct addressing mode. So that is go to this position, go to this address to find the operander, and then put that operander into the A register. Okay, so this just the address. Just the address. Okay, so next, let's show another example. So we also let's check what does this instruction mean. So you may check here the operation code. The 1110 represents store the contents of a register into the operand. Okay, and then we check the addressing mode. It is a direct addressing mode, right? Direct addressing mode. So here is this one is A, right? Okay. So this means we need to store the content of a register into this position. Okay, into this position. The content of the A register stored into this address. Why is there only one in this page? I will leave this very simple question to you after class. Okay. So next supposed to be it's an addition. Okay. We can have the immediate addressing mode and the direct addressing mode, where this is the operander and this is the address of the operander. And then we check their operation code, and it is to add some operander to the A register. Okay, so this is just to add this number directly into the A register. While this is you go to this address and obtain the real operander and added it into the A register. Okay, and then this one, character input into the operand. So it's similar, right? So you just check this one. It's a 5 bits operation code, and it's a direct addressing mode. And you go to this address and then input the character input to the operand.